Dirt should not be able to make electricity. It looks dead. It sits under your shoes, under your garden, under your driveway, and under every house on your street. People walk over it every day without thinking about it. But if you push two different metals into wet soil, connect them with a wire, and wait, something strange happens. A tiny electric current appears. No solar panel, no wind turbine, no spinning motor, no fuel, just metal, moisture, minerals, and the ground itself acting like a giant natural battery. It sounds impossible the first time you hear it. But the Earth battery is not new. It is one of those forgotten ideas that feels like it should belong in the future, but actually belongs to the past. Long before lithium packs, power banks, rooftop solar, and backup generators, inventors were already experimenting with ways to pull small amounts of electrical energy from the ground. In the 19th century, Earth batteries were tested for clocks, telegraph systems, and low-power electrical experiments. The idea was simple enough that almost anyone could understand it. Take two different metals, place them in moist soil, let the soil act like the electrolyte, connect the metals, and you have created a primitive battery. Not a powerful battery, not a battery that will run your refrigerator, not a battery that will replace the grid, but a real electrical cell using the ground itself as part of the circuit. And that is what makes it so fascinating. Because modern electricity has been made to feel complicated. It comes from power plants, substations, transformers, smart meters, panels, inverters, charge controllers, and sealed battery systems nobody is supposed to open. But the Earth battery pulls the idea back to its simplest form. Electricity is not magic. It is movement. And under the right conditions, even ordinary dirt can help create that movement. The basic setup is almost shockingly simple. One metal wants to give up electrons more easily. Another metal accepts them more easily. The moist soil between them allows ions to move. That difference creates voltage. It is the same basic principle behind a lemon battery you might have seen in school, except instead of a lemon, the electrolyte is the earth. Wet soil contains water, minerals, salts, organic matter, and countless chemical reactions happening slowly beneath the surface. It is not just dirt, it is a living chemical environment. That is why the output changes depending on where you place the battery. Dry, sandy soil may barely do anything. Moist, mineral-rich soil performs better. Clay soil can behave differently from loam. Garden soil may perform differently after rain. Even the distance between the metals, the size of the plates, the metal type, and the moisture level can change the reading on a meter. That unpredictability is one reason Earth batteries never became mainstream. But it is also why they are so interesting. You are not plugging into a perfect machine. You are tapping into an environment, and the environment matters. That is where many viral videos get this wrong. They show a few rods in the ground, a meter reading, maybe a small LED glowing, and suddenly it sounds like a secret power source that can run a home for free. That is not what an Earth battery is. An Earth battery is real, but small. It can produce voltage. It can produce current. But the amount of usable power is usually tiny compared with what modern homes consume. A single LED might be possible. A small sensor might be possible. A low-power experiment might be possible. A trickle charge over time might be possible in the right setup. But a microwave, air conditioner, washing machine, refrigerator, or electric heater? No. Those need far more power than a simple Earth battery can provide. And that is where the real story begins. Because the Earth battery did not disappear because it was fake. It disappeared because the modern world moved toward bigger and bigger electrical demands. A 19th century electrical clock needed very little. A telegraph experiment needed very little. A small signal device needed very little. But a modern home is hungry. It wants lights in every room, a fridge running all day, Wi-Fi, televisions, computers, chargers, laundry machines, air conditioning, heating systems, kitchen appliances. Once homes became power hungry, the Earth battery became too small to matter in the mainstream. But small does not mean useless. That is the mistake modern people often make. We judge old technology by asking whether it can replace the biggest modern system. Can this replace the grid? Can this power my whole house? Can this run everything? And if the answer is no, we throw it away. But older inventors often thought differently. They asked a better question. What can this do well? And the Earth battery can do something very specific. It can show that usable electrical energy can come from places we normally ignore. It can power small loads. It can teach basic electricity better than any textbook. It can support remote low-power sensors. It can serve as an emergency experiment when batteries are unavailable. It can show how chemistry, soil, water, and metal interact beneath your feet. And in more advanced forms, that idea has not disappeared at all. Scientists today study microbial fuel cells, where bacteria in soil, mud, or wastewater release electrons as they break down organic matter. These systems are not powering cities, but they are interesting for low-power devices, environmental sensors, and remote monitoring where replacing batteries is difficult. So the dirt battery did not truly die. It evolved. The simple version is 2 metals in soil. The advanced version uses biology, chemistry, and engineered electrodes to harvest tiny currents from living systems. Both ideas point to the same strange truth. The ground is not electrically dead, it is full of chemistry, and chemistry can be turned into current. That is why an Earth battery feels so powerful as a story. Not because it will free every homeowner from the electric company tomorrow, but because it challenges the way we think about energy. We are used to energy being sold to us in big packages: a solar kit, a generator, a battery bank, a utility plan, a monthly bill. But the Earth battery is almost insulting in its simplicity. A few dollars of metal, wet soil, a wire, a meter, and suddenly the ground gives you proof that power is not always where companies tell you it is. The honest truth is that an $8 Earth battery is not going to run your house. But it might light something small. It might charge something slowly. It might teach you more about electricity in one afternoon than 100 product ads ever could. And it might change the way you look at the dirt under your feet. Because once you see voltage appear from soil, you start asking different questions. How much energy is hidden in ordinary places? How many old experiments were abandoned not because they failed, but because they did not fit the scale of modern consumption? How many small, useful systems were forgotten because they could not become billion-dollar industries? The Earth battery is not a miracle. It is a reminder that power does not always begin in a power plant. Sometimes it begins with 2 metals in wet ground. Sometimes it begins with a forgotten experiment. Sometimes it begins with someone asking why the simplest ideas disappeared. And maybe that is why this old technology keeps coming back. Because in a world full of sealed devices, monthly bills, expensive battery packs, and systems too complex for ordinary people to repair, there is something almost rebellious about pushing metal into soil and watching a current appear. Small power, real power, straight from dirt. Not enough to run the modern world, but enough to prove that the world beneath us is far more alive than we were taught to believe.